All right, this is the Chapter 18 PowerPoint, question number 3, which has two parts, A and B. A buffer is made of 1.36 grams of potassium dihydrogen phosphate. Its molar mass is given here, 136 grams per mole, and 1.677 grams of sodium hydrogen phosphate. Its molar mass is given here at 142 grams per mole. First, what is the pH of the buffer? And second, what mass of potassium dihydrogen phosphate must be added to decrease the buffer pH by ½ a unit? Well, let's see if we can figure out what the buffer consists of here. Let's see, we've got sodium hydrogen phosphate, which the sodium is not going to matter, but when we put this in water, it's going to dissociate into sodium ions and hydrogen phosphate ions. The potassium dihydrogen phosphate, the potassium ions will be spectator ions, and we'll have dihydrogen phosphate. This should have a 2- charge, shouldn't it? Yep, and this has got a minus charge. So it looks like this is our conjugate acid-base system, where this over here is the conjugate acid, and this over here is the conjugate base. This is going to be a buffer problem, where we're going to use pH is pKa. That'll be the pKa of the conjugate acid, plus the log of the base form over the acid form. And both of these will be in terms of concentration, of course. All right, so I need this pKa. This problem didn't give it to me. So I'm going to pull out my book. And I'm going to check this out. Let's see. Dihydrogen phosphate, that's the acid. It gives me the Ka of 6.2 times 10 to the negative 8. All right. Yep, that's my conjugate acid. So the Ka is 6.2 times 10 to the negative 8. And remember, the pKa is going to be the negative log of this. Well, what is that? Minus log 6.2 times 10 to the negative 8. Looks like my pKa is 7.21 is what we're going to use. All right, I got to find my pH. So my pH is going to be the pKa plus the log of my base concentration over my acid concentration. So I got to figure out, let's see, this is my acid and this is my base. Let me figure out my base concentration first. All right, so I have 1.677 grams of sodium hydrogen phosphate. And I see that there's 142 grams of this, of sodium hydrogen phosphate, for every mole of the stuff. Yep. So now I know how many moles of this, and of course we know that for every 1 mole of sodium hydrogen phosphate, there's 1 mole of the hydrogen phosphate ion. Let's see what that comes out to. 1.677 divided by 142. 0.0118 moles of the stuff. Let's see, that's going to be the HPO4 2-. That's my conjugate base. That's this, so that's going to go on the numerator. Now let's do the same thing for the acid. 1.36 grams of potassium dihydrogen phosphate. And of course, we're going to take this and we are going to multiply that by, let's see, on the denominator, 136 grams of potassium hydrogen phosphate. That should be dihydrogen phosphate. For every 1 mole of the stuff. And then, of course, for every 1 mole of potassium dihydrogen phosphate, we get 1 mole of dihydrogen phosphate ion. What's that come out to? 1.36 divided by 136.01. moles of dihydrogen phosphate. Now I'm set to answer the question. You say, but wait, how am I going to find the concentration? I don't have the volume. Well, in a buffer, you don't need that if both of these are in the same volume. You're going to be dividing by some moles over liter, and this will be a certain number of moles over liter, and the volume cancels, so we don't have to worry about that. So my pH is going to be my pKa, which is 7.21, plus the log of my base. Let's see, that's this. That's the 2 minus, that's this one with the 1 hydrogen, yep. So I'm going to take 0.0118 divided by the conjugate acid, 0.01. What's that come out to? 0.0118 divided by 0.01, 1.18. So I'm going to take 7.21 plus the log of 1.18. Is that what it was? I forgot. Let me do it here. 0.0118 divided by 0.01, close parentheses, that'll work too. It looks like it comes out to 7.28. So that's part A. Part B, what mass of the acid are we going to need, the conjugate acid, are we going to need to decrease the buffer pH by 0.5? Well, let's see, we got to decrease this by 0.5. What's that come out to? 7.28 minus 0.5. 6.78. We got to drop the pH to 6.78. Well, let's figure it out. So I'll know my pH, that's going to be 6.78. That's going to be my pKa, 7.21, plus the log of my base, which will remain steady. My base will remain steady, right? Yep, because I'm adding the acid. Yep, okay. So my base is going to stay at, gotta make sure which is my base. That's that one. That's that one. 0.0118 over some amount of my acid. Well, let's subtract 7.21 from both sides. 6.78 minus 7.21, negative 0.43. That's got to equal the log of 0.118, that's moles, over x moles. Inverse of the log is 10 to the power of, so take 10 to the power both sides. This cancels. 10 raised to the power of negative 0.43. 0.372 we're going to use. 0.372, that's this, is going to equal 0.118. Oops, I got that wrong. It's 0.0118 divided by x. I'm just going to take the inverse of both sides. This is over 1. I'm just going to inverse both sides. So I flip this side, I flip this side. And if I do that, so I take both sides to the negative 1 power. And if I do that, I get 1 over 0.372. That's going to equal x over 0.0118. Multiply both sides by 0.0118. This cancels. And I get x, which I need to remember, the ratio here is moles. This is moles of the conjugate base, so this will be moles of the conjugate acid. So let's see, it's going to be 0.0118 divided by 0.372. That's going to be 0.0317 moles total of, I need that of the acid, right? Yep. Of this stuff. Oh boy, I got to think this through. What mass must be added? Well, we started with 0.01 moles, and we need 0.0317, so I better subtract out how much we started with. So I'm going to need a total of 0.0217 moles of the dihydrogen phosphate. That's what I'm going to need. All right. right. Keep going here. 0.0217 moles of dihydrogen phosphate is what I'm going to need to add. And we remember, for every mole of dihydrogen phosphate, we'll need 1 mole of, which was it? The potassium dihydrogen phosphate. Right? That's where we get it from. The potassium dihydrogen phosphate. And we're going to recall that 1 mole of potassium dihydrogen phosphate, what was that, 136 grams? Yep, it sure was. 136 grams. Man, this one's a doozy. That's a doozy. So, on 1.0217, because I had 0.01 to start. So 0.0217 times 136, I'm going to have to add almost 3 grams of this stuff. 2.95 grams of potassium dihydrogen phosphate are going to be required to be added to a system that has this many grams of potassium dihydrogen phosphate and this many grams of sodium hydrogen phosphate. I got to add about 3 grams of this stuff to pull the pH from a pH of, what did we start at? 7.28 down half a unit to 6.78.